There are many books that started the scientific revolution. For instance, what have I got here? Principia Mathematica by Isaac Newton. The Principles of Geology by Charles Lyell. And perhaps the most famous of them all, Charles Darwin's The Origin of Species. Books that set the precedent for their own field of science, that changed their understanding of other men and women as they could read a book and suddenly the wonders of biology, of geology, of physics all fell into place as one person had done the thinking before them, and it ceased to be a plethora of unconnected thoughts and it began to have form and order. Well, what about chemistry? Where was the breakthrough in chemistry that made this big difference? Well, it wasn't a book. It was a Russian man. His name is Dmitri Mendeleev, and he was professor of chemistry at St. Petersburg University. On one vacation, he went on holiday to the coast of the Black Sea, where he had his dacha. And there, all day long, and especially in the long nights, he would play cards. And he would play cards, play patience. And as he played patience, he would set the cards out on the table. And his mind must have been going through some of the problems facing chemistry at the time. Because you see, a lot of elements had been discovered. But it was just a taxonomy of different elements. There was no connection, there was no understanding, there was no thought through, grasp of why one element was different to another, what elements were the same. It was just a collection. And as he was playing cards, he began to think very carefully about some of the thoughts that had been made. One of them probably by an English chemist, John Newlands, who had realised that there was some degree of order, some degree of pattern amongst the various elements, their weights and their behaviour. And so what Dmitri Mendeleev did, our Russian professor, was he took the elements and instead of playing cards, he took pieces of paper. And on the first element, he wrote what to him was the lightest element, hydrogen. I'll just put down an H. He wrote that down. He wrote down other elements. He wrote down lithium, which he knew weighed about 3 times as much as hydrogen. He thought of another one, sodium, which he knew weighed about 11 times as much as hydrogen. As he laid them out, one by one, just as he'd been playing cards, he began to see an order. He began to see it. If he went from lithium, he went to the next one, he went to beryllium, and then he went to boron. And when he came back again to sodium, he could write sodium and put it underneath lithium. And the reason he would do that is because lithium and sodium both behave in much the same way. You add them to water, they explode. Add it to beryllium and boron to water, they don't explode. But what he noticed was that his next one, the next one heavier than sodium, would actually fit underneath boron, magnesium. And so he drew a pattern. And down here I've got an example of what we end up with from all of that. He realised that what he had was a table that moved along periodically. So it was called the periodic table. And he realised that if he put down beryllium over magnesium, calcium also behaved a little bit like magnesium. Potassium behaved like sodium and lithium, exploded in water more vigorously, and it was that little bit heavier. And as he went through, his periodic table didn't look much like this, but as he went through, a bit at a time, he began to see that there was an order in what he had. Sometimes he was very, very bold. Once or twice, he would actually change the order to go with the characteristics, the properties of the elements, thinking to himself, it can't just be their weight, there must be something else. Once or twice, there appeared to be a gap. And he was clever enough to say, in this instance, germanium, just there, hadn't been discovered as yet. He said, when this element is discovered, it'll be just a bit like silicon, the one above it in the table. He called it ecosilicon, just like silicon. And so he came up with this. And so there's no single book that has broken through chemistry. It was this table. And you see, it goes further than even Dmitri Mendeleev could ever have discovered. Because what he didn't know, what he hadn't understood, because nobody knew it then, was that each element is different in the structure of its atoms. And as you went along this way, one by one, if you went, for instance, from potassium to calcium, the very centre of the atom went up by one positive charge. The outermost part of the atom went up by a negative charge. And its mass went up as the protons and other particles with no charge, neutrons, were added to it. And here's the real understanding, the real thing you think, wow, if Dmitri had understood that, he would have blown his mind. The reason that potassium is just like sodium and that sodium is like lithium is because each of these, on the very edge of the atom, have got one solitary electron buzzing by itself. Each of these, in the next row, have got 2 electrons buzzing by themselves. 3, 4, 5, 6 and 7 along here. 8, and then we come back this way. Sometimes it's called the octet rule, the 8 rule, that brings you back down here. We get very clever when we start coming down this way because we have 2 here, we have 1 on the outer level here, 2 on the outer level there, 3 here. This way, electrons start to get pushed onto the inside bits of atoms. His pattern was far cleverer than Dmitri Mendeleev could have understood. He began to see just what chemistry is all about. Since then, every chemist has referred to this because it's unwrapped all that chemistry is about.